All right, so this is the review for test number 8. So number 1 is to expand using the log properties. Okay, so when we have AB squared and AB is in parentheses, that means they are both being squared, A and B. So that's log A squared B squared divided by C. So when we have multiplication, multiplication will separate the A squared and B squared with a plus, and then the division will separate with a minus. So I have log A squared plus log B squared minus log C squared. C, sorry, not C squared, just C. All right, the rule for the exponent is it goes in front. So I have 2 log A plus 2 log B minus log C. And of course we could factor out the 2, so that's 2 log A plus log B, close the parentheses, minus log C. Okay, so let's take a look at 1b. Okay, so for the first thing I want to do is change my radicals to fractional exponents. So I have log C. The cube root of A would be A to the 1/3 power. Remember, power over the root. And the square root of B would be B to the 1/2 power. All right, so now I'm going to separate. I have multiplication and division. So that's log C plus log A to the 1/3 power minus log B to the 1/2 power. The exponents go in front, so it's log C plus 1/3 log A minus 1/2 log B. All right, so let's take a look at C. Okay, so C is log the 4th root of AB divided by C. Now, this whole thing is underneath the 4th root. So I'm going to change them all to a fractional exponent. So it's A to the 1/4, B to the 1/4, divided by C to the 1/4. So I have log A to the 1/4 plus log B to the 1/4 minus log C to the 1/4. All the exponents go in front, so it's 1/4 log A plus 1/4 log B minus 1/4 log C. And I could factor out the 1/4 for all 3 of them, so it would be 1/4 log A plus log B minus log C. Okay, so let's take a look at number 2. Okay, so number 2 is condensing. So the first thing you want to do is take the number that's in front of your log and put it back as an exponent. So I have log x to the 1/2 power minus log y to the 2nd power. Change your fractional exponent to a radical. So 1/2 would be the square root. So I have the square root of x minus log y squared. All right, so I have a minus. A minus comes from these two being divided. So I have log the square root of x over y squared. All right, let's take a look at 2b. Okay, so since I have a 2 on the outside of the parentheses, that means it's going back to both the x and the y. So let's log x squared plus log y squared. And then the 1/2 goes back to the exponent for c. So minus log c to the 1/2 power. So my c to the 1/2 power will become the square root of c. And the x and the y squared, the x squared and the y squared, they can be written as xy because of the plus. X squared, y squared. So it's log x squared, y squared minus log the square root of c. So this is log, this here I would write as xy squared minus log c, square root of c. And then minus would be that these two are divided. So it's log xy squared divided by the square root of c. Okay, so let's take a look at number 3. Okay, so I have exponential equations. So for these, I can get the same bases. So I can write 8 with a base of 2, so it's 2 to the 3rd raised to the 3x plus 1. And I could write 32 with a base of 2, that's 2 to the 5th to the x plus 5. So once the bases are the same, the exponents are equal. So 3 times 3x plus 1 equals 5 times x plus 5. So distribute. You get 9x plus 3 equals 5x plus 25. Minus 5x minus 3. So I get 4x is equal to 22. Divide by 4, we get 22 over 4, which is 11 halves. Okay, so let's take a look at 3b. So 3b, I have 343 raised to the x minus 2 equals 1 over 49 raised to the x minus 12. All right, so you want to try to get 343 and 1 over 49 to be the same base. So 1 over 49, we would want to change that. 1 over 49 is 49 to the negative 1 power. Right, you want to get that 49 out of the denominator. So let's get the same bases. They can both be written with a base 7. So 343 with a base 7 is 7 to the third. 49 would be 7 squared, but it's going to be negative 2 to the negative 2 because I have that negative 1. Okay, so let's set the exponents equal. I have 3 times x minus 2 equals negative 2 times x minus 12. So I get 3x minus 6 equals negative 2x plus 24. Add the 2x, add the 6, so I get 5x equals 30, so x is equal to 6. All right, let's take a look at 3c. Okay, so 3c, I have a simple log equation. So you want to take it out of log form, put it into an exponential form. So remember, the base always stays the base. The base is 4, so it's 4 and then these two switch. 4 to the third is equal to x. 4 to the third, you just plug into your calculator. That is 64. All right, let's try 3d. All right, so I have log base x of 625 equals 4. Again, you're going to take it out of log form, put it back into exponential form. So it's x to the fourth equals 625. So I'm going to take the fourth root of both sides. So I get x equals, now since I'm taking an even root, you have to have plus minus. So the fourth root of 625 would be plus and minus 5. However, we cannot have a negative base. So remember, I'm solving for x and x is a base. So we can't have a negative base, and my answer is just going to be positive 5. Okay, so let's take a look at 4. So number 4 is a composition. We have f of x is equal to x plus 2, and g of x is equal to x squared minus x plus 4. And we're looking for f of g of x. So I'm looking for f of x squared minus x plus 4. So I'm going to take g and plug it in for the x for f. So I get x squared minus x plus 4 plus 2, which is x squared minus x plus 6. All right, let's take a look at 4b. All right, so 4b is written slightly different, the composition. It's g of f of x. It's the same thing as g of f of x. So I'm going to take f, and I'm going to plug it in for g. Right, so I'm looking for g of 2x plus 5. So it's 2 times 2x plus 5 squared minus 3 times 2x plus 5. And then I have minus 1. So I need to double distribute that. So that's 2x plus 5 times 2x plus 5. So that's 4x squared plus 10x plus 10x plus 25. So it's going to be 2 times 4x squared plus 20x plus 25. Distribute the 3, the negative 3. So it's negative 6x minus 15, and then I got a minus 1, and then I need to distribute the 2, so it's 8x squared plus 40x plus 50 minus 6x, and then this here is minus 16. All right, so we have need to combine like terms, so I have 8x squared, so I have 40x minus 6x, it would be positive 34x, and then I have 50 minus 16 would be positive 34. Okay, so let's take a look at 5. All right, so 5 are the log equations. So A is log base 5 of x plus 3 minus log base 5 of 3 equals log base 5 of x. So the first thing you do is you want to condense. So I have a minus, that means these two here are being divided. So I have log base 5 of x plus 3 over 3 equals log base 5 of x. So since they're equal to each other, and they have log on both sides, I can kind of get rid of the logs, and I'm just solving to make sure now that these are equal. So x plus 3 over 3 equals x. Divide both, cross multiply, sorry, so 3x equals x plus 3. Minus x from both sides, I get 2x equals 3. Divide by 2, we get 3 halves. And make sure you check, and this does check. All right, let's take a look at B. Okay, so again, we're going to condense. So I have a plus, comes from these two here being multiplied. So I have log base 2 of x times x minus 6 equals log base 2 of x plus 8. So they both have log base 2. So I could get rid of the log base 2. And just set x times x minus 6 equal to x plus 8. So I distribute the x, I get x squared minus 6x equals x plus 8. So I'm going to minus x minus 8. So I get x squared minus 7x minus 8 equals 0. And then we need to factor. So I get x minus 8 and x plus 1. T-chart, we get x is equal to 8. X is equal to negative 1. You have to check. And x equals negative 1 does not work. Only x equals 8. All right, so let's take a look at 5C. Okay, so for 5C, again, we have to condense. So it's log base 4 of x times x plus 6 equals 2. Now notice, there's not log on both sides. So you're going to have to take this and put it into exponential form. So the base is 4. So it's 4, and then these two switch. So it's 4 squared equals x times x plus 6. 16 equals x squared plus 6x minus the 16. 0 equals x squared plus 6x minus 16. We're going to factor x plus 8 and x minus 2. We get x equals positive 2 and x equals negative 8. The 2 works, the negative 8 does not work. All right, let's try 5D. Okay, so again, we have to condense. So I have log base 5 of x squared plus 9 divided by 2 equals 1. So again, I only have log on one side, so I have to put it into exponential form. So it's 5 to the first power equals x squared plus 9 over 2. Let's put this over 1 and cross multiply. 10 equals x squared plus 9. Minus 10, I get x squared minus 1. I can factor. I get x plus 1, x minus 1. T-chart, we get x is equal to negative 1 and x is equal to 1. And you have to check them, and they actually both work. So you have two solutions. All right, let's take a look at 6. Okay, so number 6 is to find the inverse. Remember, the inverse is to switch x and y. So remember, f of x is your y. So I have x is equal to 1/4 y plus 6. So we're going to put in y equals form. So I get x minus 6 equals 1/4 y when I subtract 6 from both sides. To get rid of the fraction, I'm going to multiply both sides by 4. So I get 4x, don't forget to distribute through, minus 24 equals y. And remember, to write an inverse function, it's the inverse of f of x, right? You use that negative 1, equals 4x minus 24. All right, let's take a look at B. So B is f of x is equal to the square root of x minus 3. Again, we're going to switch x and y, so we get x equals the square root of y minus 3. To get rid of a square root, you square both sides. So I get x squared equals y minus 3. Add 3, we get x squared plus 3 is equal to y. And that is the inverse of f of x is equal to x squared plus 3. All right, let's take a look at 6C. So again, we switch x and y. X equals y cubed plus 5, minus 5 from both sides. So I want to get rid of the cube, so I cube root both sides. So I get the cube root of x minus 5 equals y. So that is the inverse of f of x is equal to the cube root of x minus 5. All right, so let's take a look at number 7. Okay, so let's take a look at number 7. So we have Patty deposits $4,000 into a savings account with an annual interest rate of 2.5% compounded quarterly. If Patty makes no deposits or withdrawals, how much will Patty have in the account after 5 years, and how long will it take Patty to double her money? All right, so we want the compound interest formula. So that's A equals P times 1 plus R over N raised to the NT power. So let's just come up with a formula for this. So we have A equals 4,200 times 1 plus 0.025 over N is 4 raised to the 4t power. All right, so I have A equals 4,200 times, all right, inside the parentheses comes out to be 1.00625. All right, so the first part is I want to find out how much Patty will have in the account after 5 years. So I'm going to plug in T as 5. Okay, so you could just plug that into your calculator all at one time, and Patty will have $4,757.37. All right, the next thing we want to do is find out how long it will take for Patty's money to double. So we want her ending amount to be 8,400 equals 4,200 times 1.00625 raised to the 4t power. I'm looking for t. So divide both sides by 4,200. We get 2 equals 1.00625 to the 4t power. And now I'm going to log both sides. So it's log 2 equals 4t, 1 log 1.00625. Divide both sides by log 1.00625. So I get 4t equals, so yes, you get a nice long decimal. You get 111.249626. Just leave that in your calculator and divide both sides by 4. And we get t is equal to 27.8, which it will take her 28 years in order for her money to double. All right, let's take a look at 8. Okay, so 8 is a half-life. So we have an alien radioactive isotope has a half-life of 238 years. If you start with a sample of 8 kilograms, how much will be left after 100 years? How long will it take for only 1.5 kilograms to be left? All right, so my half-life is A equals P times 1 over 2 raised to the T over H power. All right, so let's just write our formula. A equals, the initial amount is 1/2. Is 8 times 1/2 raised to the T over, and the half-life is 238 years. All right, so we have A equals, for the first part, I want to know how much is left after 100 years. So just plug that into your calculator. And there will be 5.9 kilograms left, 5.9787 kilograms. All right, so now we want to know how long will it take for there to be 1.5 kilograms left. All right, so I do 1.5, and I'm going to divide by 8. So I get 0.1875 equals 1/2 raised to the T over 238. Log both sides. Divide both sides by log 1/2. So I get 2.41503749 equals T over 238. Put that over 1, just hit times in your calculator, multiply by 238, and we get 574.77. So it will take 575 years. All right, let's take a look at number 9. All right, so number 9, I first want to state what's the transformation from the parent function f of x, which is log base 3 of x, to get g of x. So I have a -1, that means to the right 1. And I have a +2 on the outside, which means up 2. All right, now I want to find the domain, the vertical asymptote, and x and y intercept, and I want to graph it. All right, so just plug it in your calculator in order to graph it. So my asymptote, my vertical asymptote, is x is equal to 1. So at 1 here, there is a vertical asymptote. Okay, so you can look at your table values in order to graph it. So I have 2, 2. And I have 4, 3. And I have 10, 4. So it looks like that. So remember, your log should not be hitting your asymptote. All right, so now we want the domain. The domain is from 1 to infinity. All right, now let's do the x-intercept. That's when y is equal to 0. 0 equals log base 3 of x minus 1 plus 2. So I minus 2. And I get negative 2 equals log base 3 of x minus 1. Put it in exponential form. 3 to the negative 2 equals x minus 1. Just plug that in your calculator, add 1 to both sides, and I'm just going to put, round it to nearest hundredth. So it's 1.11. So it's 1.11 comma 0. And then we need our y-intercept. So notice that it doesn't cross the y-axis, so it does not exist. All right, so let's take a look at number 10. So number 10 is the same thing. I have g of x is equal to log base 2 of x plus 5 minus 3. I want to know what's the transformation. It is to the left 5 and down 3. All right, so I want to graph it. I need my asymptote. My asymptote is at, my vertical asymptote is at x is equal to negative 5. Okay, so when we graph it, so I have negative 1, negative 1. I'm sorry, 4, negative 3. Negative 1, and 3, 0. Okay, so we need the domain. Negative 5 to 0, negative 5 to infinity. That's a negative 5. And now I want my intercept. So my x-intercept is when y is equal to 0. 0 equals log base 2 of x plus 5 minus 3. Add 3, we get 3 equals log base 2 of x plus 5. So it's 2 to the third equals x plus 5. So 2 to the third is 8. Minus 5, we get 3. So it's 3 comma 0. That makes sense. That's right there. And now I want my y-intercept. That's when x is equal to 0. Y equals log base 2 of 0 plus 5 minus 3. Plug into the calculator. And when I plug that in the calculator, I get y is equal to negative 0.678. Obviously, that's rounded. So my y-intercept is 0, comma, negative 0.678. Okay, that's it, and happy studying. Have a good night.